Hi and welcome to a course in modern Fortran. You may be wondering the logical question, why Fortran? Why now? Isn't it so old? Indeed, it was created in 1957 after all. And the truth is, it is very old, but it is also quite tried and tested. It has many libraries which have withstood the test of time. It's very robust, and it's even compatible with C. Legacy code. Of course, it is very old, so there's a lot of legacy code. At this point, there are millions of lines, so it is sort of in a COBOL-like situation in which changing so many lines of code would be an insurmountable task. It would be very, very expensive and time-consuming, so it is worth maintaining Fortran only for that reason, but it's not the only reason. It is also backward compatible. We do need those legacy codes to still be functional. You can actually compile very old Fortran, even from the first Fortran programs, and still compile it today. This is an advantage against other languages, because you know that if you produce a piece of software today, it will still be functional in Fortran for years and years to come. Finally, it is blazingly fast. It is comparable to C and C++ in terms of numerical calculations and speed, and it is highly optimized. For instance, the raw operations for mathematics, such as matrix multiplication, addition, subtraction, all basic mathematical calculations are almost optimally programmed in Fortran by default, and you do not need to import any libraries at all. Now, there's a few other things that I think are worth noting for Fortran, especially for beginners. It forces you to learn. You must know what the machine is actually representing, the number representation in binary and in different precisions, floating point, fixed point representation. It is very simple syntax-wise, at least in the mathematical operations you're going to use: addition, multiplication, division. So mathematicians, physicists, astronomers, and anyone in STEM can use Fortran pretty much from scratch very quickly. Finally, it is very modern. Fortran is not outdated at all. It is being updated constantly. Every 5 or so years, a new Fortran standard is released. And it has, for instance, object-oriented programming. Functional programming is also supported. You may define your own data types, abstract classes, and even interfaces, which allows Fortran to use C libraries as well. Personally, I have used it for physics in a high-performance computing environment, for numerical calculations of solids and light matter interaction. It is very, very fast, very easy to parallelize, and you can even use GPUs. So, what is my intention with this series in particular? First of all, I want to teach modern Fortran practices from scratch. There is an emphasis in numerical calculations and scientific computing because that's my area of expertise, and I do want to teach the older versions of Fortran to understand the modern practices as well. As for what I'm going to be using, it'll be Linux. Particularly, I have Arch Linux, NeoVim to edit text files. You may use whatever you want, VS Code, Emacs, Node++, whatever you feel comfortable with. And finally, GFortran for compilation. It is part of the GNU compiler collection, GCC, and it is freely available. So, I hope this series is worth your while and you can take something out of it. Yeah, I'm gonna want to take this one. It's going to be easy.